All right, here we are. Today's lesson is on the remainder and factor theorems. But before we get to that, we're going to do a little warm-up with dividing. So it says, consider the polynomial function x cubed. Let's get organized here. Consider it x cubed plus x squared minus 4x plus 41. Can you divide it with x plus 4? Because it's a simple linear, we could use synthetic. So we're going to go use the 0 of the divisor, negative 4. Draw this kind of long looking out looking thing. And just the coefficients. So 1x cubed, 1x squared, negative 4x, and 41. No missing power, so we're good. We're going to add 1 plus nothing's 1. We're going to multiply. Put that answer here. Add, multiply, and then recognize what the remainder is. So in this case, the remainder is positive 9. So remember that. Then we're going to do the same work, but this time we're going to plug in negative 4 and just do the math that you would do like in middle school. So, and honestly, I'm okay if you use a calculator. These numbers get kind of large, but if you did this math, I'm just going to save the expense. That when you do the math, the remainder and the substitution, what do you notice? Same answer. Let's try it again. Maybe it was a fluke. So consider this polynomial function. First, divide. And again, it's a simple divisor. So we're going to take the 0 of that, which is 9. And then 7x to the 4th, negative 63x cubed. We have no x squares, 9x, and negative 80. So just count as you go across. And if there's a missing power, there's a missing power. So in this case, 7 plus nothing is 7. 9 times 7 is 63. That's 0, that's 0, that's 0. 9 times 0 is 0, that's 9. 9 times 9 is 81, and that gives me a remainder of 1. Now, by the way, for A, if I really did divide it, the answer would have been, you go 1 degree less. So it's 1x squared minus 3x plus 8, and then the remainder is written as a fraction. So you have the remainder in the numerator, and then your divisor is the denominator. That's fine. So here, it was x to the 4th. So 1 degree less, that would be 7x cubed. No x squares, no x's. There's 1, 9, so plus 9. And then the remainder, again, would be written as a fraction. And the divisor would go in the denominator. But I want you to keep track of that. Next, I'm going to plug in 9. And then do the math. And again, I don't really want you to do the math. Like you use a calculator, 7 times 9 to the 4th minus 60. So can you see how large these numbers would be to be able to calculate? But if you believe me, if you used a calculator and typed it all in, the answer you would get is 1. But the big question here is, which one was easier to calculate? Doing this division and finding the remainder? Or if you didn't have a calculator, would this be easier? And I think if you look at it carefully, you'd recognize that synthetic division, that is easier than doing the substitution, doing my, please excuse my dear Aunt Sally, that often this leads to very large numbers that if you didn't have a calculator, it would take a longer time, you can make a mistake. Here, the numbers stay small, but yet you get the same answer. So what we're going to do today is called the remainder theorem. And a remainder theorem is if a polynomial function is divided by a simple linear, then the remainder theorem is the substitution. So if I substitute in, I could find the remainder. Or the other way is using synthetic division to evaluate a function is called synthetic substitution. So I can go in either direction because of the property we just saw. So what's more powerful than saying, oh, you could find the remainder by plugging in, is the other direction. Then instead of evaluating, we could find the remainder and get the same answer. And often the numbers stay smaller and quicker, and it gives us a more efficient way to do a substitution in a different way. So let's see this. Using synthetic division, can you evaluate this So I want to do synthetic division. I want to know this answer, f at -3. So in order to do that, I'm going to take -3, and I'm going to use synthetic division and find the remainder for the answer. So this is my goal, f at -3. So start and use synthetic division, use -3. Don't change the sign. If this said x plus 3, then you could change the sign. But for this, when c equals -3, the sign stays the same. 1 plus nothing, multiply, add, multiply, add, multiply. And then again, I'm just following it through. So what did I just find here? I'm going to write down the answer. F at -3 equals what answer? What I just did here is called synthetic substitution. Instead of taking -3 and plugging it in for the x, and the numbers get larger and larger and more difficult to use with a calculator, I can use synthetic substitution where the numbers all stayed small and get the same answer anyways. And if you practice, you can get it actually done quicker. Let's do this again. So I want to find what the answer is using synthetic division. So I want to know what f at 1 equals. So I'm going to take, I'm not changing the sign, so stay +1. And 3x to the 5th, 2x to the 4th, 4x cubed, 3x squared, 2x, and -3. No missing powers. So here we go. 3, 1 times 3, that's 5. 1 times 5, that's 9. 1 times 9, 12. 1 times 12, 14. And you get 11. Now what did we just find out? We found out that when you plug in 1, the answer is 11. So we're using a different method for substitution. Turn the page. Let's try it again. I want to know what the value is when you substitute -5 in, but I don't have a calculator, so I have a different method to do it. So I'm going to keep the sign, and I'm going to use synthetic division for substitution. Now, I don't need a 0 at the end. Or maybe I do. Maybe I should have a 0 at the end. Let me just check. I won't make it. I don't think it'll make a difference. So a 0 at the end, because we're missing a power at the end. So that is -5. That's 0, -19. A negative times a negative, that's +95. Add that up. That's 72. Multiply. It's a little bit big. That's -350 and -10. So that's -360. So it's important you didn't end there because you would have got the wrong answer. This is the correct answer. So f at -5, what's the answer? And you did substitution using what's called synthetic substitution and the remainder theorem. Let's try it again. I want to substitute -2 in and get the answer. But to get that answer, I'm going to take -2 and I'm going to do a synthetic substitution. I'm going to make sure, notice 0x squared, 2x, -1, so don't forget that missing power. So that's 2, -4, 0, 0, 0, 0, and then -4 at the end. So what I care about only is the remainder. So this remainder is my answer for the substitution. That's called the remainder theorem, and what we're doing is called synthetic substitution, a different way to substitute in to get an answer. Number 7. 7. So this is my goal, is to find f at 7. So to do that, I don't change the sign. Keep +7 with 8x cubed, -5x squared, no x's, and -1. So then we're going to do the synthetic substitution. So 7 times 8 is 56. Add this, that's 51. That's going to be 357. It's going to get a little bit larger. And then the last bit, you're going to have to go 357 times 7. So if you don't know what 357 times 7 is, we'll do it the old-fashioned way. That's 21. It's 2,499. So when I combine these together, that's 2,498. So what did I figure out? And by the way, if you plug 7 in, you'd have to go 7 times 7 times 7 times 8, 7 times 7 times -5. Like you're going to have to do, so one time multiplying isn't that big of a deal. You found the remainder. That is what f at 7 equals, 2,498. Number 8, use synthetic substitution. So if you substitute 4 in, what would that equal you doing synthetic substitution? So there's my synthetic substitution. Make sure if you're missing, I'm missing an x squared, so be careful of that. Everything else is there. Negative 2. So 4 times negative 2, that leads to negative 1. 4 times negative 1, negative 8. Negative 32, that's negative 33. And then 4 times 30 is 120. 4 times 3 is 12. So it's 120 and 12. That's negative 132. All right? What did I do wrong here? No, negative 132. Okay. Then 8 and negative 132, like you're subtracting it. So it's 124, but it's a negative 124. So what is f at 4 equal? Negative 124. And trust me, if you plugged 4 into here, it would take a lot longer, a lot more math, a lot more multiplying without a calculator. So what did we just practice? Called synthetic substitution, which means we evaluate, substitute in using synthetic division and knowing the remainder theorem. All right, number 9. The number of tickets sold during the Oakdale High School football season can be modeled by this equation, where x is the number of games played. Use the remainder theorem to find the number of tickets sold during the 7th game. So during the 7th game, we're going to do this. 7, and that's 1, negative 14, 72, and 68. That's 1, that's negative 7, that's negative 49. What is this? 12, that's 3, that's 23. So if I needed to at the end, I might have to use a calculator. I don't need to. So this is 140 and 21. So that's 161, 9, 12, 2. So how many tickets were sold? And the answer is right there. 229 tickets were sold during the 7th game. All right, another application here. The distance in feet that a person travels in a snowboard is modeled by this equation, where t is in seconds. Use the remainder theorem to find the distance traveled after 1 minute. So a little tricky. Recognize that t is in seconds, so 1 minute is equal to 60 seconds. So we're not going to use 1, we're going to use 60. And then when I substitute in, I have 0.6, I have 10t, and 0. Constant is my constant. So 0.6. Now 6 times 6 is 36. So 360. Move the decimal. That's 36. Do you see where that comes from? This is 46. If I go 60 times 46, that's 2,400 and 360. So 2,760. So again, if you needed to, you could go 60 times 46 and get that answer. Add this up. What did I just find? So the question is the distance traveled. So the distance traveled was 2,760 feet in 1 minute. Great job. Okay, that leads us to another theorem. So the remainder theorem was used for substitution. In fact, it was called synthetic substitution. That leads us to another really important theorem called the factor theorem. So given a polynomial f at x, where x minus c is a factor, then if and only if, so given a polynomial f at x where x minus c is a factor of f at x, if and only if f at c equals 0. So what this is saying is that if you want to know if something is a factor of a large polynomial, plug in, using synthetic substitution, if the remainder is 0, it is a factor. So let's practice that. So how will you know if any of these are factors of this? If the remainder is 0. So no remainder means it is a factor. That's the factor theorem. Here we go. for this one, because I'm given a factor, I need to change the sign. I need to use the 0. So the first one, I'd be using -1. Be careful of any missing terms. What did you notice? Is the remainder 0? That is a factor. Did I do something wrong? Felt like I did something wrong. Oh, a negative. That doesn't add up to 0. That adds up to 60. Not a factor. That's 60. Let's try it again properly. +5. Same numbers. 1, 0, -31, 30. Again. This one I feel better about. Definitely the remainder is 0. That is a factor. One more time for -6. 1, 0, 31, 30. Do the work. What's the remainder? 1, 0. Oh, -31. That's 5. That's -30. That is a remainder of 0. So 2 of these are factor because when you did synthetic substitution, the remainder is 0, which means it's a factor. That is called the factor theorem. Let's try it again. Which one of these is factors of this long, big polynomial? How will I know? By taking the 0 when doing synthetic substitution and seeing if the remainder is 0. So here we go. +2. 1, -6, -17, 78, -56, and don't forget the 0 at the end. So that's 1, 2, see if I can do this one right. -8, -25, -50, 28, 56. Yep. The remainder is 0. This is a factor. Let's try it again. How about x plus 7? So we start with -7. And then do the synthetic substitution. Sure I'm doing this right. This would be 71. Is that 74? This is not going to work. So once I notice the numbers get so large, so 74, if I multiply this, this is like getting close, like over 500, and then multiply it out, that's 56. This is not. As soon as I realize the remainder is not going to be 0, like it's getting too off the rails, the numbers are getting too big, it's not getting closer to 0, I can cross that one out. Let's try it one more time. Now the good news is, once you find one that works, I don't have to go back to the beginning. I can take the answer and use it to divide to make it a little quicker and shorter. So I'm going to do that. So take the answer of the one that worked and use it, and it just makes it a little bit shorter to do. So I'm going to do that. Notice the remainder is 0. So which are the two that worked and which one didn't? Using, again, this is called the factor theorem. When you do synthetic substitution and you are looking to see if the remainder is 0, and if it is a factor. All right, factoring and finding zeros. Using the factor theorem and the given binomial to completely factor the polynomial. So now the goal is to not just see if it's a factor. In fact, you're told it's a factor. But could you use that fact to factor the whole trinomial? So let's try that together. So the factor is x plus 3. So the 0 is -3. So let's start there. No missing powers. So 1, we drop. -3 times 1, add, that's 0. Multiply, that's 0. Add, multiply. We knew it worked because it said it was a factor, but this is important. What's left over? So it was x cubed. So we go 1 degree less. So that's 1x squared, no x's, and -4. Now, for what's left over, I'm going to factor that. So this is called the difference of squares. So you take the square root of each, the square root of x squared and the square root of 4, and we write it as x plus 2, x subtract 2. So now, go back to the beginning. How do I write this properly? Well, negative 3 came from this factor, x plus 3. Then, what are the next two factors we found? X plus 2, x minus 2. We have now factored out this long polynomial using the factor theorem to help us out. Can you factor this long polynomial, right, when given one factor? And there's the answer. All right, number 4. So step 1, you're given that's a factor, so take the 0. So 1, negative 2, negative 19, 20. There's the setup. So drop the 1 down, multiply. Just keep adding and multiplying. Be careful. So the remainder is 0, so that is a factor. What's left over is 1x squared plus 3x minus 4. So what two numbers multiply to negative 4 and add to 3? So that's positive 4 and negative 1. So now let's put it all together. So the first factor was x minus 5, and the two we found were x plus 4 and x minus 1. And now you've completely factored it. Let's try it again for number 5. Step 1, take the factor that's given, and we're going to divide to simplify this down. We're going to do synthetic division again. We're going to add and multiply. It's good. When the remainder is 0, that gives you a clue we did it right. We have 2x squared plus 7x minus 4. This is not a simple quadratic, so it takes a couple steps. So on the side, you would go 2 times negative 4. So I'll do that here. 2 times negative 4 is negative 8. And 7. What two numbers satisfy this? Two numbers that multiply to negative 8. 8 and negative 1. And they add to 7. So they fit. So I come back here. I take out the 7x and put in 8x minus 1x. So I did a substitution. So now I can factor this by grouping. So the first two I'll group together. They have a 2 and an x in common. And then you factor that out of each one. The next I group together, and they have a negative 1 in common. So you factor out a negative 1, and you're left with x plus 4. Notice they share x plus 4. And when you factor it out, what you're left with is 2x minus 1. So this definitely takes a few extra steps. We're not done yet. The goal was to take the original function and write it in factored form. So the first factor that was given, x minus 7, and then the two that we found, x plus 4, and 2x minus 1. Done. Number 6. Again, the factor that's given, the 0 is negative 2. That's 9, negative 18, negative 73, 2 and 8. We're going to do the division here. It's good to know the remainder is 0. What we're left with is 9x cubed minus 36x squared minus 1x plus 4. So we're going to factor this by grouping. So if I take the first two and group them, they have a 9x squared in common, and I'm left with x minus 4 when you divide. You can always multiply to make sure it's equivalent. Factor out a negative 1, and that changes the sign. So that's positive x and negative 4. Again, you can multiply to make sure they're equivalent. Recognize they have a common factor. X subtract 4. What's left over is 9x minus 1. Now we're not done yet. 9x squared subtract 1 is called the difference of squares. So the square root of 9, x squared is 3x, and the square root of 1 is 1. So one's 3x plus 1, and the other is 3x subtract 1. So now what's the answer? All the factors. So the first factor, x plus 2, and then we have x minus 4, 3x plus 1, 3x subtract 1. All right, 2 more to practice for this lesson. Number 7, you're given a factor, so we take the 0, 3, 5, negative 42, 40, and 0. So let's do the work one at a time. So again, I'm adding and multiplying as I go across here. So what I'm left with is 3x cubed minus 10x squared plus 8x plus 0, which I don't need. So I'm going to factor this further. So the first thing I notice is that there's an x that they all have in common. So I'm going to factor out an x, and I have 3x squared minus 10x plus 8. The next thing I notice is this is not simple. So on the side, I'm going to go 3 times 8 is 24 and negative 10. And it's not simple because of that 3. The only way it would be a simple trinomial to factor is if you just saw x squared or 1x squared. So what fits here? It has to be a positive one. So it's got to be and it adds up. So they both need to be negative. So it has to be negative 6 and negative 4 that work. So I'm going to come back here. I'm going to take out the negative 10 and have negative 6 and negative 4. And then I'm going to factor by grouping. So if I look here at the first two terms, they have a 3x in common. That's x minus 2. If I look at the next two, they have a negative 4 in common. That's x minus 2. And notice now they share. So I'm going to come here. I can write the final answer now. So I'm going to put this in order here. So x is a factor. I'll put that first. X plus 5 is a factor. Then we found x minus 2. And then what was left over is 3x subtract 4. And those are all the factors. All right, number 8, the last one here. Take positive 3, 4, negative 12, negative 13, 39, 9, and negative 27. So that gives me go across. So there's the remainder of 0. This is now 4x to the 4th. No x cubes minus 13x squared. No x's plus 9. And then that's what I need to factor. Now, this is in the form of a quadratic. So because it's in the form of it, I'm going to go 4 times 9. I'm going to do that over here. 4 times 9 is 36 and negative 13. I want you to recognize the two numbers here would be negative 9 and negative 4. They multiply to 36 and add to negative 13. So when I do a substitution, it's going to be negative 9x squared, negative 4x squared plus 9. Then I'm going to factor by grouping. So I'm going to take out a 4x squared. That's x. No, I'm going to take out an x squared, sorry. That's going to be 4x squared minus 9. I'm going to take out a negative 4, and that's going to be x squared minus... No, I'm just going to take out a negative 1, and that's going to be 4x squared minus 9. So they both have that. So I have x squared minus 1. I have 4x squared minus 9. Both of these are a difference of squares. So this is x plus 1, x minus 1. This one, take the square root of each one. That's 2x plus 3 and 2x subtract 3. So now let's put it all together. Hopefully I have room. The first factor was x minus 3, then x plus 1, x minus 1. Here we have 2x plus 3 and 2x subtract 3. So here we had a very high order polynomial. You're given one factor. From what was remaining after you divide it out, I continued to factor by grouping and a difference of squares, and it ended up being this. All right, that is the remainder theorem and the factor theorem. So Mr. G Math, over now.